Determine the least common multiple of the following polynomials. Let's start by expanding the factors of each of the given polynomials. So we're going to write 9 as 3 times 3. And we have the x to the 7th times the y to the 5th. For the second expression, we will write the 10 using 2 times 5, and we have the x to the 4th times y to the 9th. So to find the least common multiple, here's what our thought process can be, right? We want both expressions to match. We want to have the same factors that multiply to give us the same number. For the numerical coefficient in both expressions, we want both expressions to have the same number of x's, and we want both expressions to have the same number of y's. So we can keep this simple. Starting with our numerical coefficients, we have 3 times 3 for the first expression and 2 times 5 for the second expression. Those factors are different in both expressions. So what that means is, for the first expression, I will multiply the 2 times 5 here. For the second expression, I will multiply 3 times 3. Now we can say that both expressions have 2 times 5 times 3 times 3. All right, let's move to the x's. The first expression has 7 x's. That's what x to the 7th means, right? The second expression has x to the 4th, so it has 4 x's. In order for both expressions to have the same number of x's, I can simply go to my second expression and multiply it times x to the 3rd. That will give me 7 x's in my second expression. Now both expressions have x to the 7th. So now let's compare the y's. The first expression has y to the 5th. It has 5 y's. The second expression has y to the 9th. For both expressions to have the same number of y's, I can go to the first expression and multiply it times y to the 4th. Now both expressions have 9 y's. Both expressions have y to the 9th. So when we multiply both expressions now, both of those expressions will give me the same polynomial. 2 times 5 times 3 times 3, 3 times 3 times 2 times 5, right? Together, that gives me 90. For my x's, both expressions have x to the 7th, and both expressions have y to the 9th. So the least common multiple is 90 x to the 7th, y to the 9th. Determine the least common multiple of the given polynomials. First, with this question, both polynomials must be factored. So for x squared plus 8x plus 15y squared, we will factor. Of course, we'll use our factoring method, so we're not going to go over the factoring portion here, but we'll factor using x plus 3y times x plus 5y. For the second polynomial, x squared minus 25y squared, the factors are x minus 5y times x plus 5y. So once you have completed your steps for factoring both polynomials, now what we want to do is examine both sets of factors, and we want those sets of factors to match. I want to have the same factors for my first polynomial as I do for the second polynomial. Here's what I mean. For the first polynomial, we have an x plus 3. For the second set of for the first polynomial, we have the factor x plus 3. But for the second set of polynomial factors, we do not. So I want to multiply the x plus 3y into this second set of factors. When I compare the second set of factors, it has an x minus 5y, but the first set of factors does not. So I will multiply the x minus 5y times the first set of factors. Compare both sets of factors now. And we see that both sets of factors has an x plus 3y, an x plus 5y, and an x minus 5y. This gives us our least common multiple, which is x plus 3y times x plus 5y times x minus 5y.